such as line graphs or bar graphs. Instead, it refers to a set of vertices, that is, points or nodes, and of edges, or lines, that connect the vertices. When any two vertices are joined by more than one edge, the graph is called a multigraph. A graph that loops and, with at most one edge between any two vertices is called a simple graph. Unless stated otherwise, graph is assumed to refer to a simple graph. When each vertex is connected by an edge to every other vertex, the graph is called a complete graph. When appropriate, a direction may be assigned to each edge to produce what is known as a directed graph, or the book embedding is a generalization of planar embedding of the graph to embeddings into a book, a collection of half-planes all having the same line as their boundary. Usually, the vertices of the graph are required to line. Find a latent vector representation of graphs which captures the topology, in very basic sense, of the graph. We can roughly divide embeddings into two groups, which is vertex embeddings, and graph. Graph embeddings are the transformation of property graphs to a vector or a set of vectors. Embedding should capture the graph topology, vertex-to-vertex relationship, and other relevant information about graphs, subgraphs, and vertices. Graph embedding are a specific type of embedding that translate graphs, or parts of graphs, fixed-length vectors, or tensors. For example, this is from a deep white paper. You have your graph. You could represent it as an adjacency matrix. You've one hot encoded which node is attached to which other node. It's a large matrix and it's going to be very sparse. So your embedding just translates that into a much smaller matrix, lower dimensional that you can then use for some kind of task. So what we're doing is we're learning